NASA has lost contact with Voyager 2. All because of a wrong command. On July 21, NASA flight controllers sent a series of commands toward Voyager 2. Unfortunately, the packet contained an erroneous command that caused the probe's antenna to deviate by about 2 degrees. This was enough for NASA to lose contact with Voyager 2. Voyager 2 was launched into space in 1977. A few weeks after that, a twin structure, the Voyager I probe, was launched from Earth. The mission of the probes was to explore the outer planets of the solar system. As part of it, a flight near Jupiter and Saturn was planned. The mission was planned for 4 years, but was constantly extended. Uranus and Neptune were the first targets of the probes, and then it was decided to cross the border. Literally. Because the Voyagers were meant to reach the heliosphere, and beyond. The heliosphere is especially important for life on Earth, because thanks to the magnetic field present in it, we are protected from dangerous cosmic radiation. Both probes crossed the boundary of the heliosphere, Voyager I in 2012 and Voyager II in 2018, providing us with the first in situ measurements of this changing boundary. At the edge of the heliosphere, called the heliopause, the solar wind loses its speed and the pressure of the galactic winds begins to outweigh the pressure of the solar wind. Several decades have passed since the completion of the Voyager's primary mission of exploring the gas giants in the solar system. Currently, the twin structures are the only man-made objects that have crossed the boundaries of the heliosphere and reached interstellar space, providing humanity with observations like no other scientific instrument. Both structures are powered by radioisotope thermoelectric generators, which are getting worse every year. According to NASA estimates, around 2025 generators may no longer be able to provide adequate power for operation. Perhaps a system upgrade can improve the situation. Earlier this year, improvements were made to Voyager II's systems in hopes of extending its lifespan. On July 21, flight controllers sent Voyager 2 a packet of commands. Unfortunately, an accidentally sent erroneous command caused Voyager II's antenna to change orientation by about 2 degrees, causing communication to be interrupted. As a result, Voyager 2 is unable to send or receive messages via the Deep Space Network's global antenna network. NASA said it was using its instruments to look for any stray signals from Voyager 2, which is currently more than 19 billion kilometers from Earth. It takes over 18 hours for a signal from such a great distance to reach Earth. It should be noted that the probe is doing well and is probably sending messages, but the stream of data escapes into space instead of reaching the antennas of the Deep Space Network. NASA also intends to bomb the vicinity of Voyager 2 with the appropriate command, in the hope of hitting the target. However, experts are sure that the failure is temporary. The probe has a built-in periodic antenna alignment system. Also, if a command to correct the antenna's orientation fails, NASA will have to wait until October 15 for an automatic antenna reset, which should restore communications. Until then, Voyager 2 is moving according to the planned trajectory. Communication with the Voyager I probe works without problems. This ship is now nearly 24 billion kilometers from Earth. The Gulf Stream, on which the climate in Europe depends, is weakening faster and faster. For hundreds of years, the Gulf Stream has not been as weak as it has been in recent decades, say scientists from Ireland, Germany and the UK. Their reconstruction of water circulation in the Atlantic, based on analyses of ocean sediments and ice cores, indicates that the changes that took place in the 20th century were unprecedented in the past millennium and are probably related to climate change caused by man. The water circulation system in the Atlantic Ocean plays a key role in regulating the global climate and significantly affects the weather in Europe. The Gulf Stream transports huge amounts of heat from the tropics to the far north, significantly influencing the climate throughout Europe. Currently, it is the weakest in hundreds of years, which is related to human activity and global warming, according to the latest findings of scientists. The constantly moving subsurface water circulation system is called the Global Transmission Belt, or, more technically, the thermohaline circulation. Its Atlantic part is called the Atlantic Meridional Overturning Circulation, AMOC, and it includes the Gulf Stream, which sends warm and salty water from the equatorial regions to the North Atlantic, where heat is released into the atmosphere, which in turn, it warms Western Europe. Then the waters around Labrador and Greenland cool and become denser before sinking to great depths and returning south. According to scientists whose research has been published in the Proceedings of the National Academy of Sciences, climate change will significantly accelerate the weakening of these currents, which in turn will change the face of the climate in Europe and the US East Coast. Changes in ocean currents can have a significant impact on weather, which in turn will affect biodiversity, agriculture and economic stability in many countries around the world. Scientists have evidence that the rate of ice melting in the Arctic is affecting the weakening of the Gulf Stream. According to the new models, the Earth will soon reach a tipping point beyond which it will be impossible to stop galloping changes. This is disturbing news. If they are confirmed, we have little time to act, argues physicist Johannes Lohmann from the University of Copenhagen in Denmark. Johannes Lohmann and Peter Ditlevsen developed a climate model in which they took into account the increased rate of freshwater flow into the northern parts of the Atlantic Ocean. This water comes from, among others, melting glaciers in Greenland. All previous studies assumed that glaciers would melt more slowly. The new model showed that the weakening of the AMOC would progress more rapidly as the amount of glacial water flowing into the ocean increased. This means that the Gulf Stream will disappear sooner than previously predicted. Once that happens, humans will no longer have much influence over the climate systems that keep global weather patterns in check today. The same problem also threatens other climate subsystems around the world. The Gulf Stream can be compared to a river flowing in the ocean. This powerful seawater conveyor belt redistributes heat in the northern hemisphere. It is partly thanks to the Gulf Stream that winters at higher latitudes in Europe are relatively mild. Ocean current scientists have noticed that in recent years the Gulf Stream has weakened faster than previously predicted. According to researchers, this is related to global warming caused by human activity. After all, melting cold fresh water from Greenland's glaciers is likely to keep warm water from flowing north. And this could completely disrupt Europe's climate. Scientists emphasize that creating climate change models is extremely complicated due to the need to take into account a huge number of different factors. Lohmann and Ditlevsen believe there is still a long way to go and want to continue their research. Experts hope the latest results will mobilize people and governments to take faster action on the climate crisis and greenhouse gas emissions.